Hello friends, welcome to my channel Gate Logic. In this video, I'm going to take you through the programming, the UART, and setting up the UART service on the DE10-nano. But before I do that, I want to share the device that this is going to be replacing. That is this giant mess. I'm calling it a mess, although it's working exactly as I programmed it to do and hasn't given me a problem ever. But yet, because of the amount of wiring and and hardware that's exposed to the elements, I have to worry about the weather. I have to worry about the bugs, and the open circuit like this can easily be short-circuited by a small bug. So I want to transfer this into the D10-nano. That's basically what I want to do. Now, another reason I'm sharing this is to just give you a little bit of highlight what each of these components do. As you can see that it has D10 nanos, 4 of them. This one's the master, and you can see that there are 2 wires going to the other nanos. This is a I2C connection going from the master, and these are 3 slaves. This one's controlling the focus. These 2 are controlling the axes, controls declination and right ascension. And this is right here. This is the current controller of the stepper motor. The third one is this chip right here. I don't remember the chip model right now, but I'll share that in the description. And you see this little thing right here. This is the 5-volt converter. So essentially, what's going on here is that this connector, through this connector, I supply 12 volts, which goes directly to the motors. So the 12 volt is the maximum power. Basically, I'm sending the maximum power to the motors. That 12 volts is also converted to 5 volts, which goes to the Arduinos. Very simple. It's basically the programming in these that I have to convert and transfer to the D10-nano. Okay, so this is the background of the device, and basically this is the drive. And let me demonstrate to you how this actually functions. Not exactly every aspect of it, just the front end communication with the master. This way you'll see exactly what I'm trying to transfer it into the D10-nano. Okay, it works over the USB, connecting the USB to my laptop. So that's connected. Okay, so as before, I'm going to open the Minicom port. The port setup is USB 0, 9600 baud rate, 8-bit, 1-stop bit. So you can see that this is receiving traffic and it says INI, and then basically it's constantly sending this INI out, and it's waiting for the client to respond with the same INI. So once the Arduino receives this INI, it will then sync with the client. I sent the INI to it. You didn't see the exact typed characters because there's no return character from the master, from the Arduino. Basically now it's in sync. Now it's not sending the INI anymore, and now I can request something from this master, and I can say, okay, basically this whole setup is on get and set commands. So I'm going to say that get right ascension RPM, and this is how it replies. Okay, so now I want to discuss a little bit about the development environment. I've chosen NetBeans version 25, and this one is downloaded from the Ubuntu App Center, and it's available from the App Center. You can download it as well. And I noticed that there are two different versions available. Also, the NetBeans can be installed from the NetBeans website through a download method, and they have the same latest version available. You can choose that, and if you're finding any issues with your IDE platform, you can download the older versions, find which one of the versions work for you, and download that one. Okay, now I'm going to disconnect this Arduino setup. and bring back our D10-nano here. Now, as you saw, the Arduino was ready to program. This is also ready to program, but not through USB. You see, this has a mini USB connection, which you can connect to your laptop, and it creates a virtual, or it creates an Ethernet connection, a TCP/IP connection. Through that, what we're going to do is we're going to program this device. Instead of treating it like a computer, we will program it remotely through that TCP/IP connection. So let me demonstrate that. I connect that to my laptop. Now at this time, I'm not connecting my USB for the UART. That we can do later. For now, what I want to demonstrate to you is the remote connection method through the NetBeans. Okay, right now I'm in Programs tab. There is a Services tab you would have to go to, and I already have this connection created for the D10-nano. Let me remove this so you can see exactly how it's done. And I'm going to recreate. As you notice, this is under C++ build hosts. And I'm going to do add new host. In the host name, I'm going to write root. The IP address is 7.1. Root is the username I'm connecting with. The Linux on this D10-nano is set up for that user only at this time. You can modify it as you want in your platform, but right now for development purposes, I'm going to leave it as is. This user comes built into the default image that we burn on the mini SD card. And now I'm going to say next. Right now it cannot establish connection to the port 22. Let me see what's going on. So the ping is going through. Ping is going through just fine. We don't have any proxy. Okay, in the host name, we're going to type in the IP address. And I'll say no proxy here. And we go to next. Once you're in the next window, this means that the connection is seen, or the D10-nano is seen by this environment. And all you have to do is apply the login. Login I've chosen to be the root. This is the default user that is set up on this image right now. So, and use next. It'll connect, configure host, and there you go. The connection is ready. Right now it's showing green. If you can notice this, the green screen, very tiny icon here. This connection is connected, and if you right click it, the connect option will be disabled, like this one. Connect option is enabled right now. That means this is disconnected. So we're connected to the D10-nano right now. And what I will do is I will keep our local host connection open. And let's see what the D10-nano has. It is telling us exactly what libraries it has. It has make tool, assembler, debugger. So D10-nano on this image is set up with the default C++ and C compilers. Okay, let's go back to our code. I've also opened or extracted my original code from the Jetson Nano, which is currently the web server or the host for the telescope that I use. And it used this serial connection to connect to the Arduino that I shared earlier with you. Now what I want to do is I want to create a new project, but this new project, I want to create this new project in the DE10-nano environment in here. So let's see if we get this option, or maybe I can do it from here instead. Let's see if I have the option. Oh, there it is. Yeah. Okay, I have this option. Let me try the other way first. What I was going to do is click this and see if there's a option I'm given here to choose a different environment. I don't see the choice here. This one, if you click this plus sign to create the new project, you will be creating it on your own laptop. So at the time, I don't know if there's another way, but I know this is the way I've used in the past, and we'll use this. So I select that, and I'm going to use C++, C and C++ application option. And here I'm going to specify exactly where my project should be, what it should be named. This will be UART CG4 UART. And let's see if I can specify exactly where I can dump this project. Okay, we'll keep it in the documents then. Let's keep it in the NetBeans projects. Leave it there. And we'll do finish. Let's go back to our projects. Let's see if it created CG4 UART. And it tells us exactly where it's located. It's on our 192.168.7.1 address. Let's open the source file, main CPP. Okay, I'm running into some kind of a bug right now. Let me try again. Okay, folks, so I discovered that my NetBeans IDE version 25 was not compatible with the Java, and I believe I'm running Java version 27 at the moment. Let me pull that up. One moment. So yeah, utilizing this Java -version command, you can find out exactly which version your Ubuntu environment is installed with. This is the default one. There's another command you can execute to actually choose if you have multiple Java JDK environment installed in your Ubuntu, you can choose which one to run by default. So this is the default one I have, and I believe there's another version on my Ubuntu. One moment. So if you run update alternatives config Java, hold on. Let me make sure that is the correct command. Alternatives. Yeah, I believe the spelling is correct. Yep. Oh, it's a single dash. Okay, here we go. So currently my Ubuntu environment has 3 different JDK installed, or actually 2. One is in auto mode right now, version 21. I also have a version 8 OpenJDK installed, and I can choose if any one of my environments or any one of the or any program that utilizes Java version 8 OpenJDK, I can switch using this command. So sudo update alternatives config Java. So okay, we're not going to change that. It's going to stay at 0, which is our 21, which works with our NetBeans. So let's continue here. So I installed IDE version 20, created the same root connection to my D10-nano, and as you can see that everything is good. The icon is green. It's very small, but it is green. And I've already connected to the program that I created in that D10-nano. So the program is loaded, and while I was debugging, I was so frustrated that I just kept on working, didn't realize that I have to record this portion of the progress. So I apologize for that, but there's some progress. It's pretty much copied from my other programs. As you can see, I have other programs open, and there is a standard code that I have over the time matured, and it works very well on a server environment. It basically utilizes this fd set method. Fd set is set, and there's a clear somewhere here as well. So anyways, this fd method looks for any changes in the file that is associated to our UART connection in this case. And as soon as it sees any change, it breaks the loop, or I apologize, it doesn't break the loop, but it basically breaks this for loop and takes us into the next step. And in the next one, I can then just find out which one of the file references that is the changes associated to, and I can then run my dedicated procedure or list of commands. So basically, in this case, this is what's going on, and going all the way up here, you'll see that I am using this open port. The open port, it's basically a simple open connection method, and it looks at the read and write, no delay, takes in it also takes in this flag, which basically in which we basically declare the baud rate and the stop bit options and other options. I'm not actually familiar with all these options. Right now, let's focus on creating a simple UART program. And since this is already filled in so much, I don't want to mix this with our example. So I want to create a second UART program. Let's close this, and I'll keep the changes. Keep the changes, please. I'm going to say, oh, create a new project. It's going to be another application. Yes, please. And in our case, we have a CG4 UART. Let's keep it the same location. So this is going to be UART test. And what I'll do is, again, the approach is still the same. What I'll do is I'll create a UART connection, and this connection will just send out a simple message. And in our case, I do want a good example in front of me. So let's keep this existing one open. And what I'm going to do is take the open port procedure and basically make it work for us. And here we are. Okay, so this is utilizing some libraries. We want to make sure that all those libraries are present in our new program. The time, error, and all these types and select. Select was actually the interrupt method that I'm using in the select. So in our example, we won't be utilizing it. So I believe I have grouped all the essentials here. And I'm going to copy them over. As you can see, IO stream, we want that. We want file control, IO for read and write, standard lib for print methods, printf methods, and I believe terminal IOS is write for write. Well, I'll find out. Let's see if there's any library that's missing. It will scream at us. So we'll look at the debug response. So okay, so open port, and the next thing in the open port we usually do is we open the port, which is right here. First thing it will do is open the port. SRL FD is basically a integer. We'll keep it local, and as soon as it opens, if it is less than 0, it's going to close, and it will return to 0. Basically, the program will stop if the port is if the port doesn't open. Let's say if there's what's going to happen is when our USB, let's see our USB here, if this one is disconnected and the program tries to open the port, it will say, hey, I cannot open the port, and it will return a -1, and that's where this closing port response will be seen in our console. So now the next step after this, what I can do is take up to this point, the port will be opened because all the code to open the port is already in here and it's functioning, and I know this is going to function right. I don't want to get into the explanation of this because there are multiple functions that I would have to explain. So at this point, I want to just use my code here and just demonstrate the serial connection, a working serial connection to you. So, and reply is, I believe, it's inside one of these. I'm going to take the right. There's my reply. Oh, one more thing. I am using, in this case, I'm using a buffer. It's a standard buffer. I have to import that as well here. I like to use standard fixed length buffers. They are easy to predict. So if I know my message is going to be maximum 50 characters and the message exceeds any more than that, the program's going to crash. So if I keep my message to 50 characters, everything's going to be fine and easy to predict. Now here we are. Let's see. We're going to write the buffer. In this case, let's bring this into a while statement. This will take this into a loop. All right. So this will forever loop. And let's just wait for, is this available? Yes, it is. Okay, so sleep. This is in seconds. So every 5 seconds, it's just going to say ACK, ACK over and over. And yeah, I believe this is fine. Okay, let's compile our code. Set this as main. Oh, our response or program response from this program won't show up in the console. It will show up in our Minicom on my laptop. Okay, so okay, Minicom is open on my laptop, listening to USB 0 connection. Let's go back here and let's run this. It's a UART connection now. Okay, let's see if there's any other issues with this code. Looks like it's clean. Okay, let me see. Our Minicom is still functional. I'm going to, let's remove our video for a second. Move this over. Okay, now my Minicom is running on the side, on the right side. NetBeans is on the left. Every 5 seconds it should send a acknowledge. There you go. So yeah, UART is working and it's sending the message. Fine, it's open, and this is what I want to demonstrate in this portion of the video. Now let's do a couple of more steps. Let's take a couple of more steps again and turn this into a service, which is which is easy. What we can do, let's stop this first. What we can do is basically, first of all, let's connect to our board. And what we will do is find out let's find out where our turn this off as well. Okay, what we'll do is find out where our services are stored. So in my laptop, I know the location is system, no, nothing. There is syscontrol system D. There's system D, yeah. System D. Okay, so it's in system D. And let's see if there's something in the system. Syslog service. I have target once. That's good. That's good. Okay, so now let's do a little bit research, and I'll come back with a service creation method. That will save us some time. Okay. Okay, we're back, and I have a simple example in front of me. And what I'll do is, so first I have set my path to etc system md system, and here, as you can see, there are other services that are set up. What I'll do, I'll create a file in here that says cg4 UART service, and in here I'm going to paste this code. Essentially what we want this file to do is point to our executable. In this case it's this right now, but we'll put our executable in a good location and point this execute start to that executable. And then there's a timer as well. I believe there's a timer restart if the service crashes. Let's say if somebody unplugs the UART connection, service will crash. But we don't want to. We don't want the service to stay crash. We want the service to restart again. Let's say after 3 seconds. And let's see. Do I have this example? I do not. So let me pull up my Jetson Nano, the server that is hosting multiple services for camera, for serial connection. Let me take one of those examples and plug it in here, and that way you'll see exactly what the service looks like, and we will have just a copy paste method to continue. You will have just a copy paste. In that case, we will continue quickly, and this demonstration will be straightforward to you. Okay, so what I've done is basically connected to my Jetson Nano and pulled up one of my services. This is a very simple layout. You can see I have description, it says exactly when to start up, basically as soon as the network is up, and it's going to execute this CG4 camp server, and it is located in this path. Now this portion I don't remember exactly why I did that. To me it looks like that the bin environment is basically running this camp server app as a service, and it basically set to always restart after 3 seconds. So if the service fails 3 seconds after, it's going to restart again. So that way the service stays up and until basically service stays up and connects to the next connection instance. So now what I want to do, replicate this exactly as is into my UART program, or for my UART program into the DE10-nano. And let's say, let me see if I can copy paste this across in this manner. Can I do that? Well, it does work to this point. Okay, let's move the cursor up here. There we go. This is not CG4. This is going to be my drive. As soon as the embedded network is up and running, well, let me take it back. So the network in this case will not be connected. So I don't want this to wait for the network, because network will not start up in this case. What I want to do is link this to something that starts up instead of network, even within the apps, let's say even in the absence of the network. So this I have to change. Let's do this after. Let me fix the other portion. And the other is basically, I'll take this whole section here for the service, put that down here, remove all these garbage example, and I'll place mine in this, not this exact location, but okay, let's leave it up here for now. Going to be multi-user target. Okay, let's come back. Oh yes, so okay, so what this service is going to be named as. So let's say, going back to my service and my program. For now, it is sitting in distribution UART test. That's where this is located. This is located, and I'm going to take the path of this, path of this file. Now it's always going to run 3 seconds after, and now I don't have to create a special space for it. It's going to run from its nested space inside the folder, and I'm going to say save. Save in our case is Control O, write out, wrote 14 lines, exit, and let's turn this into a service. So how I can turn this into a service? So what I need to do now is tell the system control, well, I need to be sudo mode first, sudo systemctl enable, well, not enable, but yeah, enable, and my enable, this is going to be cg4 UART.service, and yes, sudo doesn't like sudo. Oh, I'm already running in root. Oh, don't need to do sudo. Fail to enable unit, invalid argument. So I have to reload the daemon. Oh, this is an embedded. So, well, I mean, let me just run it. Let's see what happens here. So this is a system control daemon reload. Okay, reload it. And then I'm going to do start or enable. Oh, it still doesn't like it. It's not loaded properly. Invalid documents. See system logs for details. It's not loaded properly. I'm not running anything, am I? It's in off mode, yes it is. And there is no other, let me execute. X this out. No. It is not starting. Invalid argument. Okay, let's not start it as a service. Let's start it directly from this location. So this was our location. Now hold on. Okay. And you're saying that my location. This is my location. And no such file or directory. UART test. It says not present there. Should be in distribution location, but it's not there. It's clearly running. Exit my connection from my Jetson Nano. And traffic is there. So the service is running from the source. Stop that service now. Can I run it without? No such file or directory. For some reason it doesn't like to, it cannot see it in that location. Okay, might as well change it to that location. So cd, we're going to go to that instead of running this. It's here and it runs. It runs. So what is happening? Okay, so it runs, but it does not run using our argument. So I think what we want to do is look up our argument. I think there's something wrong here. Maybe this was the issue. Bin environment. Is this present? User bin environment. So let's see user bin environment. Is there a user bin environment? It is present. Well, was that the... Oh yeah, it was. Okay, so just because the path was in the next line, our bin environment couldn't find that file. Okay, so that's what happened. Now it started the service, so it should be running without us doing anything. There it is running. Okay, what happens when I disconnect? Okay, so let me bring up the camera first. My camera, where you are, video is good. Okay, FYI, my video is a little bit of lag, so sometimes I'm moving my hands in the video and my words aren't following what I'm doing with my hands. So all right, I'm going to unplug it. unplug. Cannot open port. There's no port there. What's going on with my service? Let's see the status. Status is it's running. Should have stopped, but it's not stopped. Okay, you're not stopped. Fine, that's fine. Let's see if it comes back when I reconnect. Yes, okay, service is still up. It is working perfectly. Okay, now another test I want to do before I exit this. I want to move this over. Okay, before I exit and end this session, I want to do another test. It's basically a power or reboot test. So this service should come on automatically and should not be a problem. Okay, let's stop or shut down our D10-nano. Shutting down. Let's see what happens here. It's still receiving some traffic. I guess I have to pull the power. Okay, let's pull the power. 1, 2, 3, go. Oh, damn. All right. Plugging back in. Oh, some garbage. So there's still some console activity. Maybe another program other than Getty is using console. Let's see if our service can take over after it's done, or this whatever this program is, after it's done. Let's see if our program can take over from that point on. Still something coming up. Don't see an activity. No activity light. No activity light so far. What do I do? Just I don't need a sudo for minicom. Reconnect again. And let's check our status. It's disconnected. Inactive dead. I believe it didn't run a enable. Okay, enabled. and start and start. Okay, so enable start, fine. I'm going to say shut down. Oh, there we go, shutting down, stopping C-Drive UART. It should, sorry, I apologize. It switched to 9600 baud rate, and I'm receiving some traffic out of this. This is insane. So there's still some other, there are still some other services that are occupying this connection. Okay, fine. Let's see. System is halted. All good. I'm going to reconnect power. You'll see some garbage come through again. UART connection on my laptop on my left is still functional. Receiving garbage. Oh, okay. So right in the middle of it, there are other other programs that still occupying that board. Okay, fine, fine for now. This is fine. Until I discover how to disable access altogether to this board. I will consider this an okay situation for me as I continue to develop. As I continue to develop, I'm sure that at some point I will find a solution to this issue. So for now, this is fine. Our service kicks in right after the console mode stops, and everything is well and good. It's going to send acknowledge, or in our case, what I'll do is program this to send INI, and then once it receives the INI and the message syncs, the device will go into ready mode, and it will start receiving get and set commands. So for now, this is good. Thank you folks for watching this video. Please don't forget to subscribe, and I'll meet you in the next one.